Now, let us see what is load. The word load is quite familiar to us. We all know the meaning of word load. But when we talk about CEM, what does the word load refers to? So let us just see the definition of load and what are different types of load. So load is basically combined effect of external forces acting on a body. Again, I am repeating, a load is a combination of different external forces acting on any body. So a load may be defined as combined effect of external forces acting on a body, right? So there are various forces which act on a body. When you see them or when you consider them, it is termed as load. Now, there are different types of load. One by one we will see what are these different kinds of load. Let us first consider dead load. As the word suggests, it is a dead load. Dead load means it is not in living condition or it is not live load, right? So it won't change any conditions, right? So dead load is a load whose magnitude remain constant over the time. A load whose magnitude remain constant over the time is termed as dead load. Here you can see in the picture that there are two poles and on the pole there is one beam, this beam of 10 meter length and 600 feet diameter, and this is the width, right? So weight of structures such as wall, plaster, ceiling, beams, column, roof, etc. all these weight of structures are termed as dead load, because it will remain same or constant with passage of time, right? So here you can see at any moment of time, if you will see, the load on these two pillars will remain same. The next one is live or fluctuating load. A load whose magnitude changes over time is known as a live or a fluctuating load. So whenever there is a change in magnitude or amount of load with respect to time, then it is termed as live or fluctuating load. Clear? For an example, a load of vehicle on the bridge is termed as a fluctuating load, because at any given time the number of vehicles on the bridge may differ, and due to that difference the load on the bridge may differ, right? So here one more example is there. People and furniture inside this particular room are termed as live load, because they may change the amount of furniture or the pieces of furniture, and the number of people inside that room may change with respect to time. So it is considered as a live or fluctuating load. The next one is inertia load. So what do we mean by the word inertia load? It is the resistance of the body to change in the direction and speed. Again, inertia load is the resistance of the body to change in the direction and speed, right? So here you can see the example. We all have done this kind of activity in our childhood. Just take a glass and on top of the glass keep one paper, right? And on that paper or cardboard keep one coin. When you will pull that cardboard or paper with a force instantly, then coin will not move with that cardboard or paper, but rather it will fall inside the glass. So it is termed as inertia load, right? So when the cardboard is pulled, the coin falls into the glass. This is because the inertia of coin maintain its state, right? So inertia of coin will remain as it is, and due to that the change in position of coin does not take place, and at rest will be the position for coin. So coin will remain at the position of rest, and it falls inside the glass due to gravity when we pull the paper or cardboard over which we have put the coin. The next comes centrifugal load. So what do we mean by centrifugal load? It is a load which simulates the effect of entire model spinning about its axis. Clear? So centrifugal load is a load which simulates the effect of entire model spinning about axis you specify. So it always acts in the direction opposite to direction of acceleration, right? So this is a centrifugal force. It will always act opposite to the direction of acceleration. Then comes a tensile load. So when two bodies or when two equal and opposite pulls are applied on a given body in the same line of action, this is very important. When you apply pull in opposite direction but in the same line of action, then it is said that it is subjected to a tensile load. Then that load is termed as tensile load, right? So the result of the application of tensile load is that length of the body is increased and thickness will be reduced, because you are pulling it from both the sides and in opposite direction, keeping it in the linear mode, right? So that is our tensile load. Then comes compressive load. So what do we mean by a compressive load? When two equal and opposite pushes, are applied on a body in the same line. When two equal and opposite pushes are applied in the same body in the same line, right, then it is said to subjected to compressive load. The result of this will be length of the body will be decreased and thickness is increased. Clear? So this is a compressive load. The next load which we will see is a torsional load. So what do we understand by the word torsional load? It is the load which impart the turning movement or turning motion, right, in any object, or it can also be termed as a load which impart torque to any object is termed as torsional load. Here you can see in this particular figure that this is a cylinder, right? If it rotates about its axis, this is a torsional load which is responsible for its rotation, right? When any object rotates, there is always a torsional load which is associated with that particular object, right? So this is a torsional load. Next comes bending load. As the name itself suggests, bending load, a load which is responsible for bending of any object, right? So let's just see what is the exact definition of bending load. The bending load is a load which is applied perpendicular to the longitudinal axis, right? And this will result in bending of that particular object or member. Then it is termed as a bending load. Here you can see this is a beam or a beam which is fixed at one end. So when you will apply force perpendicular to it, there will be some bending experienced by this particular beam. And this bending is due to the bending load, right? The next load is a shearing load. What is a shearing load? When two equal and opposite load having opposite directions. Again, remember, two equal and opposite load, but the direction of that load are opposite, right? Two equal and opposite load having opposite directions and different line of action. This is very important. They must have opposite direction and they must have different line of action. Right, when they act on any given body, that body is then subjected to a shearing load. Both of them act from opposite sides, so it will turn or change the shape of that particular object. Right, so this is a shearing load. Last one is distributed load. So what do we mean by a distributed load? The word distributed itself is enough for us to understand the particular kind of load. When a distributed load is one in which the load is entirely distributed or spread in some manner over the length of that particular object, right? When the particular load is distributed in some particular manner over the object, then it is termed as distributed load. Here you can see in the picture, right, that this is the beam and there is a load W, but that load is equally distributed over the length L. Right, over the length L, the load is equally distributed. These arrows, down comma arrows, shows distribution of load. So this is all about load and what are different categories of load which we have encountered. I just hope all the topics which we have covered today regarding load, what is load, what are different categories of load and where we can apply these kind of load is quite clear for us. Because this particular concept we are going to adapt in our upcoming topics for distribution of load and for resolution of forces on the given body. So I just hope today's lecture is quite clear to everyone and I just hope that all the different types of load and its application is clear. Thank you.